Hello world. I'm Imagination. Today I am going to talk about prosthetics. In medicine, a prosthesis, plural, prostheses, from ancient Greek prosthesis, addition, application, attachment, or prosthetic implant is an artificial device that replaces a missing body part, which may be lost through trauma, disease, or a condition present at birth, congenital disorder. Prostheses are intended to restore the normal functions of the missing body part. Amputee rehabilitation is primarily coordinated by a physiatrist as part of an interdisciplinary team consisting of physiatrists, prosthetists, nurses, physical therapists, and occupational therapists. Prostheses can be created by hand or with computer-aided design, CAD, a software interface that helps creators design and analyze the creation with computer-generated 2D and 3D graphics as well as analysis and optimization tools. For the past 7 years, researchers in Sweden have been studying a new type of mind-controlled prosthetic arm that could drastically improve the lives of people who've lost a limb. The arm prosthesis is implanted through a process called osseointegration, in which the prosthesis is surgically attached to the bone, muscles, and nerves. The technology involves implanting electrodes that pick up on the brain signals and allows people to move, feel, and use the new limb in an intuitive, natural way. A new report published in the New England Journal of Medicine on Thursday assessed the effectiveness of the new prosthesis and found it could successfully be used daily in a variety of personal and professional activities. An implant gets attached inside the bone of the remaining limb via osseointegration, which essentially extends the skeleton to where the prosthetic arm can be attached. Then, electrodes are implanted in the patient's nerves and muscles. When those electrodes pick up on a signal, for example, a person wants to move their finger, they're fed through an artificial intelligence algorithm that tells the prosthetic limb what to do: move the finger. The finger moves. It is a true extension of the patient's extremity, prosthetic. Within science fiction, and, more recently, within the scientific community, there has been consideration given to using advanced prostheses to replace healthy body parts with artificial mechanisms and systems to improve function. The morality and desirability of such technologies are being debated by transhumanists, other ethicists, and others in general. Several theorists have explored the meaning and implications of prosthetic extension of the body. Elizabeth Grosh writes, "Creatures use tools, ornaments, and appliances to augment their bodily capacities. Are their bodies lacking something, which they need to replace with artificial or substitute organs? Or conversely, should prostheses be understood, in terms of aesthetic reorganization and proliferation, as the consequence of an inventiveness that functions beyond and perhaps in defiance of pragmatic need?" Elaine Scarry argues that every artifact recreates and extends the body. Chairs supplement the skeleton, tools append the hands, clothing augments the skin. In Scarry's thinking, furniture and houses are neither more nor less interior to the human body than the food it absorbs, nor are they fundamentally different from such sophisticated prosthetics as artificial lungs, eyes and kidneys. The consumption of manufactured things turns the body inside out, opening it up to and as the culture of objects. Mark Wigley, a professor of architecture, continues this line of thinking about how architecture supplements our natural capabilities, and argues that a blurring of identity is produced by all prostheses. Some of this work relies on Freud's earlier characterization of man's relation to objects as one of extension. Creating superhumans is not too far away. What is, perhaps, even more fascinating about the research taking place is what these discoveries could mean for the future of health as a whole. If the part of the brain that is responsible for memory becomes damaged, scientists could effectively bridge the gap between what is supposed to be sending a signal, and what is supposed to be receiving it. And if that can be done, then we can open up new possibilities for people affected by depression, Alzheimer's disease, sensory loss, stroke, or other cognitive or movement disorders. The landscape that lies before us is quite wide because the nervous system interacts with basically every body part that we have. The commercial potential is quite large. The future of this field is bright, fascinating, and unknown. Beginning to restore touch is just the beginning. With the studies these individuals are engaging in, it may just be possible to one day restore the very nature of who we are, and make us even better than we've ever been before. If you can make bad things good, can you make good things even better? That's all for today. Thanks for watching.